earlier this week we did simplifying square roots because you needed to do that in order to be able to answer the Pythagorean theorem questions in the simplest form. Today we're going to learn about multiplying and dividing square roots, which you'll need for what we'll do, I guess it'll be middle of next week. So let's take a look at these problems. There's a couple of different types. You won't see this type very often, but you will see it occasionally. What we're going to do is simplify the square root of 72 and just multiply it by 4. So we're keeping the 4, but then we want to simplify the square root of 72. Now, to simplify the square root of 72, you have multiple options. You can do perfect square factorization. You can do prime factorization. And with prime factorization, you can do it as a factor tree, or you can do it as a tower or a ladder, depending on which way you see it. I imagine most of you are going to start with 72 and go, okay, that's 8 times 9. And then 8 I can divide into 4 and 2. And the 9 I can divide into 3 and 3. And then with the 4 it's 2 and 2. So remember, these are two square roots multiplied together. The square root of 2 times the square root of 2 is? 2. The square root of 3 times the square root of 3 is? 3. And what do I have still left over?
4 and 2.
I don't have the 4 left over.
You have only 2.
We have this still left over. So it is still a square root. 4 times 2 is 8. 8 times 3 is 24. This is 24 square roots of 2. This next type, you're going to have a lot of these throughout the rest of the unit. So for example, if you have 7 square roots of 2 times the square root of 2, what we want to do is, at least mentally, most people don't take the time to write this, and that's fine. We're going to put parentheses around those 2 because the square root of 2 times the square root of 2 is 2. So this is just 7 times 2. Which is 14. That's going to happen anytime the square roots you're multiplying together are the same square root. All right, then here, they're not the same, so we're still going to group the square roots together. That's 11 square roots of 15. If I think about, yes?
Would we need to factor out the 15?
Well, that's what I was just about to say. If we factor the 15, what are the factors going to be?
5 and 3.
Are there any that are alike?
No.
If there are none that are alike, it's not going to simplify.
Okay.
So this is our answer in simplest form. As opposed to the next one that we're going to do doesn't turn out that way. The square root of 15 times the square root of 3. 15 times 3 is what? 45. So this is 12 square roots of 45. Now we need to simplify the square root of 45. Again, I think for that one, I know it's faster, and I think it's easier. What's a perfect square that divides evenly into 45? 9. So that's 12 times 3 square roots of 5 is 36 times the square root of 5. If you don't like doing it that way, simplify the square root of 45 just like we did earlier this week. And then multiply that result times 12. It'll come out the same way. It's just when you can see a perfect square factorization like that, it's faster to do it this way. All right, let's do this. 19 square roots of 6 times the square root of 2. Again, we're going to group those two together. So that's 19 square roots of 12. What's a perfect square number that divides evenly into 12? 4. Thank you. 4 goes into 12 3 times. The square root of 4 is what? 2. That's why we picked it, because it turned out to be a perfect square. 19 times 2 is 38, so this is 38 square roots of 3. Some of you who are pretty good with numbers will get to the place where you can skip a lot of these steps, and that's fine. All right, that's multiplying with square roots. Now let's do dividing. Dividing with square roots is a little bit harder than multiplying with square roots. Okay, and there's a rule that's an additional rule that you don't have to worry about when you're multiplying, and that is that when you're dividing, you can't leave a square root in the denominator. So when you get finished, we usually write these in fractional form, but there can't be any square roots on bottom. If there's a square root on bottom, then you haven't simplified it completely. So, for this one, this is one of the easiest ones that you'll ever see. 17 square roots of 2 divided by the square root of 2. What's the square root of 2 divided by the square root of 2?
2.
No, I'm not asking that question. You got to listen to the question. The square root of 2 times the square root of 2 is 2. The square root of 2 divided by the square root of 2 is 1. A number divided by itself gives you 1. And 17 times 1 is just 17. You'll have some problems where you have to do this on your test. It'll be part of a bigger problem, but yeah. All right, what if they're not the same? Well, it depends. I'm going to rewrite this as 84 square roots of 15 over the square root of 3. Will 3 divide evenly into 15?
Yes.
So the square root of 15 divided by the square root of 3 is the square root of 5. You must always check that first. I'm going to teach you something else that for some of you it's going to drive out the easy ones. Don't let it drive out the easy ones. So, yes.
I thought you said we couldn't leave a square root in the
No, what does it say? Read what it says. Can't have a square root in the denominator. I don't even have a denominator anymore. Okay?
Yeah, I understand.
All right. Let's take a look at this one. That's 16 divided by the square root of 2. And unlike the previous two questions, I can't divide these because 16 is not under the square root. They're not the same kind of numbers. There's a simple trick. There's a simple trick to doing this. What we're going to do is multiply by 1. And you're like, what is that going to do? Well, it's going to fix everything, but you have to multiply by 1 in the correct form. The form of 1 that we're going to use is the square root of 2 over the square root of 2. Does everyone agree that the square root of 2 over the square root of 2 is 1? Okay. Now let's multiply. In the numerator, 16 times the square root of 2, well, that's 16 square roots of 2. In the denominator, the square root of 2 times the square root of 2 is
1,
One.
2.
Two.
Oh.
I'm just kidding, guys.
the square root of 2 times the square root of 2 is 2. You got to pay attention to what the operation is. And now 16 divided by 2, since those are both whole numbers, is 8. So that's 8 square roots of 2. All right. Same idea for this one. All right, stop. If you have to yawn, that's fine, but cover your mouth and don't make any noise.
Sorry.
Yawning is involuntary. Making noise is voluntary. So I want to get rid of this square root of 3 on bottom in the denominator. So I'm going to multiply by the square root of 3 over the square root of 3. This is 23 square roots of 3 over 3. Will 3 divide evenly into 23?
No.
No. So stop. Don't do anything more on that problem. This is called, you guys are cracking me up, this is called rationalizing the denominator. It's called that because a square root of 2 or the square root of 3 is something that's called an irrational number. It's irrational because you can't write it as the ratio of 2 whole numbers. All right, we're going to do 2 more. And yes, I know, you only see 1 on there. We're going to add 1 more. So this is 42 square roots of 2 over the square root of 3. Don't let the square root of 2 in the numerator bother you. We're still trying to get rid of the square root of 3 on bottom. So we're going to multiply by the square root of 3 over the square root of 3. What's the square root of 2 times the square root of 3? Square root of 6. So this is 42 square roots of 6 over 3. (42) is evenly divisible by 3.
Yes.
So that's 14 square roots of 6. One last example. (18) square roots of 2 divided by the square root of 2. So what am I going to do? Cancel them out, thank you. Right? Because the square root of 2 divided by the square root of 2 is 1. So that's 18. Don't forget about the easy ones. All right, I have a worksheet for you. And then we'll take a look at your quiz.
Oh, you're showing the PSAT data.
Yes, I know.
Oh, fun.
It doesn't have any names on it, so it's how students improved from when they took it in 10th grade to where they took it in 11th grade.
Oh.
'Cause you do want them to improve. And mostly people did.
That's
There were
good.
a couple of exceptions.
Yeah, that's how it always
Sit down, please.
Sorry. Wait, I don't know.
All right, shh. Matthew, sit down.
I'm sorry.
For my sanity.
All right. Be happy to answer any questions you have on the quiz. Yes, ma'am.
Can you do number 6?
Yes, ma'am.
Like, I got confused because I thought if two of the sides are congruent, or like if every side is congruent, then the last one has to be congruent.
So think about it for just a second. If I take these two sides, could I also have done that? So there is no third side theorem. There's a third angle theorem and the reason why that works is because no matter what size the triangle is, the angles have to add up to 180. But the sides don't have to add up to anything in particular. Okay, shh, yes,
Okay, can we go over number 10?
sure. All right, so for number 10, just for time's sake, I'm not going to write down all of the given. We have that angle M is congruent to angle P. If A is the midpoint of segment MP, so MP gets cut in half. So segment MA is congruent to segment AP. Please be quiet. Other people are quiet when you are asking questions. That's the definition of a midpoint. Shh. Then I need to have the vertical angles are congruent. Angle MAN is congruent to angle PAC because vertical angles are congruent. Now that's enough to prove the two triangles congruent. Triangle MAN is congruent to triangle PAC by angle, side, angle. And then the corresponding sides are congruent by the definition of congruent triangles. Yes, Arturo? Yes. Celeste, did you get what you needed out of that?
I think so. The only thing is that I guess, I don't know how to explain it. I just didn't know how to write the given. So I would have like the right thing, except instead of putting MAN, I would put like N is congruent to C. So.
We don't know that N and C are congruent.
I know. I just got confused.
Okay.
Wait, can you put my duck?
All right. Shh. For this one, we've got angle T is congruent to angle R. If we bisect angle TAR, which is over here, these two angles at A are the two angles that are going to be congruent. Angle TAS is congruent to angle RAS by the definition of angle bisector. Then we'll use the reflexive property to say that SA is congruent to SA. By the reflexive property. And that's enough to prove the triangle's congruent. Triangle STA is congruent to triangle SRA by angle, angle, side. Okay? Yes, sir.
Can you do one question about the number 2, the second
So, reason number 3?
After the given. the one right
All right.
after.
So how do I know that these are right angles? By the definition of perpendicular lines.
Oh my god.
They told me that we have perpendicular lines. If you have perpendicular lines, then you have to have right angles.
I forgot that.
All right, what other questions do you guys have? Yes, sir.
5 and 6.
5 and 6, all right. We already did 6.
Oh, no, on the back.
Oh,
Or number 12.
so you guys have a great weekend. This is hypotenuse leg, and this is triangle RAS. And once you have the triangles congruent, you prove the corresponding parts congruent by the definition of congruent triangles.
Mr. Davis, I know like you have to go to carpool duty, so I'll just come back. Never mind.
Okay.
Mr. Davis. So I see, I think as I'm looking at it, I see a lot of mistakes I made. Like on this one, I didn't know what was going on, so I just put I put this thing.
Right, but you can't
Yeah.
just add that.
Yeah, I understood that when I looked at it, and I forgot to mark these as congruent, which would have been
Right.
angle, side, angle.
There you go.
And
Yep.
then on this one, it's angle, side, and I did the same thing, but they don't give you anything here, so that would just
Right.
be done, right?
Well, you can add that, and it's angle side side, but side side angle, angle side side, that's not one of the things we can use.
So this one will be done.
Yes.
And then what about this one? I don't know what this one was.
So when you've got parallel lines, here you can add those because those are alternate interior angles.
That's the one that would.
Yeah, if the lines are parallel, you can add that. On this one, you can't because we don't know the lines are parallel. Same thing here.
Because and this one says it with this, right?
Correct.
Got it. Okay. So and that one. So those mistakes I had.
Okay.
Yeah. All right. Thank you.
Yeah, much better.
I almost forgot my phone again.
It's when you leave late.